Up until now, we've been storing variables independent of one another. Sure, those variables can get a little complicated if they are themselves objects, but ultimately, none of our variables are really associated with one another. For example, let's say that we have a variable that's an int and we're asking a user how many of something. And then we have a separate variable that is their response. These variables don't know anything about each other. It's up to us to associate them. But as you can imagine, over time, when you have a lot of variables that are associated with one another, you might want an actual construct to physically link them. When you want to have multiple associated variables, sometimes you need an object for that. Let's take the example of a student. A student has lots of pieces of information that they need to know about themselves and how they function within the school. You need to know their name, their student ID number, maybe they have a GPA, maybe they have a class schedule, et cetera, et cetera. All of those individual pieces of information are going to be associated with a student. And there's probably lots of different students. So if you want to have the name, the ID, the class schedule for each individual student, you're going to have a lot of individual variables. Here's just some code for those variables for 2 students. Imagine if you had an actual school filled with thousands of students. How would you manage all these variables? Well, what you can do is you can actually create your own object. Here's that code from before. Here's that code reorganized as a separate object. What we've done is we've taken the individual pieces of information that we know are consistent across all students, and we've put them in a separate file. That file is called student.java, and it starts like all our other files have: public, class, and then a name. However, if you look inside, there's no main method. There's actually just a list of variables, but without any values associated with them. These are the fields, and these are the individual pieces of information that are always going to be associated with, in our example, a student. Then, when we write the code to figure out who's graduating, that's where we find our main method. And as you can see, now the word student has become a keyword in Java. I can have a type of variable called student with a capital S, and I can call new, and it will give me a new student. And all of that code that was individually labeled variables, goodness, I hope I get the names right, is all stored within a single variable name. Here we have 2 students, Ada and Alan, and they each keep all of their information well packaged within a single variable. That variable being of type student object. What is an object? An object is a combination of what we call state and behavior. In our student example, the state is all of the pieces of information about a particular student. So their grades and IDs and classes, things like that. Their behavior is all the different things they can do. So within our code to manage our students, maybe we want to know when they can graduate or help them change classes, or they need to get their transcripts. All of that stuff requires the information on the above line. So the above line is their state and the below line is their behavior. Surprise, you've been using objects all along. I'm sure you've heard us use this word before. All of the objects you've been using were created in the manner we're teaching you now. For example, strings are an object. Their state is whatever characters you've strung together. Then they have lots of behavior you're probably pretty accomplished with now. The dot equals method, that's a behavior that you act on 2 separate strings. Because somebody wrote the code for the string object, and every time you call new, you create a different version of that string object that has the same type of state, though it has different values, but can use the same behavior. That's why learning all your string methods has been really useful. Let's take a look at our student object code. At the very top, we have the state. Those are the individual pieces of information that we store for each student. Right here. In the context of objects, we call them fields. Each separate instance or individual copy of a student has its own state, meaning each individual student probably has their own personal name and their own GPA. And all of those are the same type of variables, but with different values. Then students and objects have behavior. These are the different things they can do. Here's an example of one piece of student behavior. It's a single method, but behavior actually refers to all of the different methods within an object class. So let's say that we have a new object that helps us write the blueprints for a house, which makes sense because our object code is actually kind of like the blueprints for another object. So I write a class that defines how a house functions. We need to know its color, we need to know its square footage, does it have a balcony, does it have a backyard? And then we can do different things with that information. We can construct a floor plan, or we can figure out how much paint we have to buy. This code that I write is very generic. It's like, okay, I know all houses have these things in common. But then later on, when I make a new house, I can fill in the specific information. So for example, I could say, this house is blue and it doesn't have a balcony. Based on that information, I can do that same behavior. Now, because I have my blueprint object code, I can create as many new instances of that object as I want. And they could all have different values. They could be beige or yellow houses. They could have different square footages, but they all conform to the same outline that I designed in my object code, or the blueprint for whenever anyone makes a new object. So, how do you get your object code to run? There's no main method. You know in Java that the computer looks for the main method and starts at the very top line. So when you try to run your object code, you'll probably get an error that says no executable found. That's because your object has to always pair with a file that is executable. Here's our student object code. It's in a separate file called student.java, and it's in the same folder as our student manager class. The student manager class has a main method in it, just like we've been writing all along. But you can see inside of that main method, I'm using the keyword student like it's always existed. That's because by having these two files in the same folder, now I can use my object just like it's a part of Java. The student code is called the object, no main method. The student manager code is called the client. It has a main method, and it's using the student like a tool. It's a client of the student's options that it provides. And when I'm in my client and I use the keyword new, I create a new instance of my student, and I can use it however I see appropriate. I can make as many students as I want. This is how you really adapt Java to fit your personal needs, and how you're going to simplify a lot of your complex organizations of data and all of your different methods. When you think about how to restructure your programs within the context of objects, your programs can get a lot more advanced. Now, sometimes it's hard to understand the separation between the object and the client, but don't worry. As you practice more, you'll understand exactly what an object is and how clients can put them to best use.